Hello everyone, welcome back to my tutorial. This time we will be talking about 2D transformations. What are the basic 2D transformations and the matrix representation of those 2D transformation, composite transformation, computational efficiency, homogeneous representation, matrix composition. Now what is 2D transformations? Geometric transformations are the operations applied to geometrical description of an object to change its position, orientation, or size. Now, why do we need transformation? Transformations are needed to manipulate the initially created object and to display the modified object without having to redraw it. So we may manipulate the existing object to serve our purpose. Okay. These are the three basic transformations. In this tutorial, we will be talking about translation, and in the next tutorial, we will be talking about rotation and scaling. What are the applications of transformation? As we can see, the transformation is applied in an animation to give life or virtual reality. Okay. We use parameterized transformation that change over time t. Thus, for each frame, the object moves a little further, just like a movie. So in animation, as we use transformation, we will see an object moving around. Okay. Now let us first see the translation. As you can see, this cube, if we are going to translate it, let's see how and what can happen. Okay. So in translation, the size of the object does not change at all, but the position of the object changes. All right. Let us see rotation. You see this cube. When you apply rotation, now it is rotating around the same axis. Okay. In terms of scaling, now this object has increased in size or decreased in size when we apply scaling parameters. Now let us try to see those translation again one more time. Translation, rotation, and scaling. Okay. Now we will be talking about 2D translation. A translation of a single point is achieved by adding an offset to its coordinates so as to generate a new coordinate position. So this building on the x-axis started at point number 2, and on the y-axis it started at point number 1. Okay, so if we apply this shift vector or translation parameter tx will be on the x-axis and ty will be on the y-axis. So if we add this translation true on the x-axis, this particular point will become 4, as you can see, 1 2 3 4 here. Okay, and on the y-axis, if we add 3, already 1 1 2 3, it should be on the 4, 1 2 3 4. Okay, now the object will change its position. In translation, size is not reduced or manipulated, or the orientation is not manipulated. Now this is the translation operation. X dash is equals to x plus tx. That means the new value of the x, the new value coordinate on the x-axis will be equals to the original coordinate point plus the translation or shift vector. Okay. On the y-axis, the new coordinate points on the y-axis, y dash will be equals to the original y plus the shift vector on the y-axis. It's very simple. Now, this formula can be written in matrix form. X dash y dash equals to x y plus dx dy. This is the translation matrix. All right. Do not get confused on the matrix form. It's all the same. X dash will be equals to x plus dx. Y dash will be equals to y plus dx, which is similar to this translation operation. All right. Knowing all those things, let us try to find an example. Translate the triangle having points A, true, true, and B, 10, true, and C, 5, 5 by Tx equals to 5 and Ty equals to 6. We have here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis, and 1, 2, 3, 4, 5 on the y-axis. All right. So the points A, let's see the points A here, true and true. This is your first point A, and B, 10 and true. This is your point B. C will be 5. Here is your 5, and here is your 5. This is your point, and this is your C. And when we draw this, we have a triangle here. All right. So doesn't look that good. Now we have to translate this triangle dx by no. Let us modify this. Let's not say 5. Let's say 2. And this also let's us just say 3. We already know that x dash is equals to original x plus dx. Okay, so using this value, let us see all the new values of y dash, new value of a, b dash, c dash on the x-axis. You simply have to add. Okay, now let us see the first point, that is x dash will be equals to 2 plus 2. 2 is your dx. All right, so what we have now here is 4, which is equals to 4. All right, and likewise you will have 10 plus 2, which is 12, and likewise you will have 5 plus 2, which is 7. Now on the y-axis also, y dash is equals to original y plus dy. Therefore we can have 2 plus 3. Your dy is 3. 2 plus 3 is 5. 2 plus 3 is again 5. And 5 plus 2 is again, 5 plus 3 is again 8. So this is your new coordinates. Now we can plot the new coordinates point like this. Here, this is your 0 on the x-axis. This is your y-axis. So we have 1, 2, 3, 4, 12, 13, 14, so on. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's stop there. Now let's see the coordinates of a dash, which is 4, 5. Here is 4 and here is 5. So this is your a dash. And C, b dash, which is 12 here, 12, and 5 here. So it will be around here. This is the point. This is your b dash. Now C, this is your 7 and this is your 8. Okay, this is your C dash. The triangle does not change its size or orientation. The angle is still the same. Here the angle here will be the same as this angle. This angle will be same as this angle. Here will be the same as here. Okay, so everything will be the same except that it will change its position. As you can see, from 0 it is becoming so much wider as compared to this distance. Okay, now that is translation. Thank you very much. See you in the next class.